Okay, let's go ahead and get started. Okay, Cassidy,
Here.
Alejandro, Liliana,
Here.
Lainey,
Here.
Cassandra, Romeo,
Here.
Here.
Brenda,
Here.
okay, Jasmine,
Here.
Josue, Jade, Valerie,
Here.
Edsel,
Here.
Joel,
Here.
Joel is here, Monique,
Here.
okay, Salvador,
Here.
okay, Caitlin,
Here.
Kayla,
Here.
Romeo,
Here.
Paola, Ricardo,
Here.
oh, Joel is here, okay. Okay, so no Alejandro?
I'm here.
Alejandro's here?
Yeah.
Okay, Josue or Jade or Paola? Oh, Paola's here? Okay. Nice. Okay. Okay, let's do something right now. Let's just kind of see where everybody's at in the class so far. Okay, I'm concerned about the low test grades at this point. Hopefully we can raise those up. We've got two exams left and a final, so hopefully it'll be all good. Okay, so I'm gonna go to the grade book here, and I want to export it. Get rid of the get rid of the names here. What I'm really interested in is this here. Let's go back to sharing my screen. So again, I teach statistics as well as calculus, as well as this class, I guess. So let's see what the distribution of the grades in the class is so far. So oops. Okay, so let's get out of that. Let's go here. Okay, and let's go over here. current score. That's what I'm looking for. Current score here. Okay, so I'm gonna highlight this one. Okay. I'm gonna highlight this here, and I'm gonna input. I'm gonna go to the insert, and I want a chart. I'm gonna go to my recommended charts here. So they're gonna say, oh, we want to recommend what charts do you want? Well, I actually want a histogram for this. Let's see a histogram here. Okay. So 0 to 32, 32. Okay, so I'm just going to hit OK on this. Okay, so it's going to give me a histogram. This is the grade distribution so far. Okay, it looks okay when we look like this, 0 to 32. I'm going to change the parameters of this chart though. We don't really look at it like bunching them together. Who's failing and who's not failing. We want to look at, you know, basically what does the distribution look like? So I'm gonna go down here to my axis. I'm gonna double click on my axis, and I'm gonna try to format axis. Here we go. Format axis. Axis options. Horizontal axis. I don't want the text. I don't want to format the axis. I want to change my bin width. Let's see if I can do that. Okay, so this, there we go. Chart options, here we go. Okay, so properties, size, no, don't want that. Shadow, no, no. Okay. I want to change my bin width. Why is it not letting me change my bin width? I don't want the chart area. I just want the axes. Horizontal axis. Okay, let me try it one more time. And then I'll give up. But delete this bad boy. If I can. Okay, let's try it one more time. Let's insert a chart. Okay, so insert chart. Chart. I want a histogram. Charts. Charts. Let's try this again. Histogram. Where's my histograms? There it is. Histograms. Okay. I got this bad boy here. Okay. And I want to, from that plot area, I want to chart area. There we go. Axis options. Nice. Bin width. We do not want bins of 32. What do we want bins of? We want bins of 10. Okay. Why? Because that breaks it down to show, okay, the grade distribution in here. Okay. So here's the grade distribution in the by grades. Okay. So we can see it's kind of a bell-shaped curve in a way. Okay, except we have 1, 2, 3, 4, 5, 6 people that are getting below 50%. These 6 people, I'm concerned about I don't know if you were ready for college level math or not, but if you currently have lower than a 50% in this class, you're gonna have to change your behavior. If you don't change your behavior, you're not gonna end up passing the class. Okay, I'm just letting you know that right now. Okay, if you fall somewhere in these 6 people, okay, then yeah, you're gonna need to change your ways. Okay, seriously, or you're just gonna continue to fail the class. Okay, you can't not do the homework, you cannot not turn in the worksheets, and you cannot not turn in the projects. If you don't turn in anything, then there's nothing that I can grade. Okay, the homework, projects, and worksheet, that's there to pad your grade, so that when you don't do well on an exam, you don't fail the course. Okay, it's kind of like with the homework, you know, it's kind of like walking by an ATM and the ATM is spitting out $20 bills and you're like, you know what? I'm a little too lazy to just go over there and grab that $20 bill. Right? And it's like, well, okay, fine. Then you lose out. Right? So then somebody between a 50 and 60, that could just be low test grades. Okay, not necessarily you know, lack of work. Okay, and then we have 60 to 70. Okay, we have 4 people in that range. That just means that you're right on the cusp. It means that we need to you know, do a little bit more. You'll be within passing range. And then we have 5, 6, 11, 10 people in the course that are doing fine. Okay, you're at 70% or above, which is good. It's, you know, good for your first time. I have 4 people that are just blowing it out of the water here. They're 90 to 100%. Okay, so just kind of wanted to talk to each of the people that fall in each of these categories. Okay, and you know where you are. So again, I don't know, again, if you were ready for college level material, but it would be nice to get this thing to the other side. Okay. Now compare this to my other class, which there's no comparison. You want to see my other class? Here, I'll show you my other class here. Okay, so let me do that real quick. Okay. So this is the class right after you guys. So okay, I need to download this file. Shoot, did it get downloaded? Yeah, it did. Okay, good. Okay, so now I'm going to do the same thing that I just did. Okay, current score, that's what I want. Okay, and not everybody's doing well in this class, but this is more of what I would expect at a college level of, you know, you're like, these people are in their probably 3rd year of community college. Okay, and they figured it out. They figured out how to be a college student at this point. Because if you look at this one, let's add a let's insert a chart for this one. Do the same thing that we did before. Let's create a histogram. Okay, and we're going to go click OK on this one. I'm going to change the bin width. Bin width here is 20. I want it to be 10. Okay, so 10, bin width of 10. You're going to see the difference. No, is it 10? Bin width is 10. Here, I'm gonna actually put in a 0, just so that I get nicer bins. That didn't work. Of course it didn't work, because I'm an idiot. Okay, I don't want to, I just want to highlight. There we go. Okay, and click on this, go down, boom, there we go. Okay, so now look at that. Did you see a difference in the distribution of grades here from this class versus, now there's still 2 people, 3 people, well, there's 2 people that are failing. Okay, still there's 2 people failing the class, yet, and I have 1, 2, 3 people that I'm concerned about. Okay, these people I'm just going to end up dropping pretty soon here, or they're just going to drop themselves. Okay, and I'm going to be left with these people over here. Notice that it's a completely different type of curve, right? Notice what the majority of the grades are in my class, in this class here. Okay, I've got 13 A's. 13 A's in this class, right? And I've got 7 B's. So 20 students are getting an A or B, right? Compare that to your class, right? I've got 4, 5. I've got 5 students getting an A or B in your guys' class. I've got 20 in the other. Okay, what's the difference? Well, maybe the difference is just taking the class seriously. Okay, so just want to give you a heads up. Okay, college is different than high school. Okay, I taught high school for 11 years. I know. Okay, there's no hand holding here. Okay, there's no spoon feeding. We don't spoon feed you in college. You're either going to do the work and you're going to pass, or you're not going to do the work and you're going to fail. Okay, so does that help? Does that make sense? Hopefully. Don't save. Don't save. Okay, so I guess that's my little stick. Right, there's the carrot and the stick. So, okay. Yeah, absolutely. So, I mean, that's kind of the stick. The carrot is that, you know, that we still have 3/5 of the class left in front of us. We have 2 exams and a final. Okay, and you still have plenty of time to redeem yourself if you so choose to. So that's kind of the moral of that story. Okay, let's get into today's material. Okay, we'll finish up chapter 8. Okay. Okay, let me log in with my tablet and then we'll get to it. Yeah, now it is somewhat of an unfair comparison, the one class to the other, and I'll let you know why it's a tad unfair. The other class that I teach right after this is Calculus 3. So I'm basically teaching all engineering students in that class. So the subject matter is insanely harder than this one. And so it's kind of like by then the students either have figured out that they're serious or you know, why would you go into that major if you weren't a serious student, right? And you've already proved yourself that you can get to that level by then. So, but again, you know, they're working their asses off. I mean, it just goes to show, you know, they want a certain degree and they're going to earn it and they're going to have to work for it. You know, you guys want to pass the class, you're going to have to work for it. You have to earn it. So nothing's given to you in life for free. Okay, so at least it wasn't for me. let me share my screen here. You know, my mother was an alcoholic and my father was a drug addict. I grew up in Southern California. I didn't find out who my biological father was until I was 44 years old. So not all of us have it easy. You know, some of us had to pull ourselves up and work our butts off to get anything in this life. So I know that I'm preaching to the choir on this one too, because I'm sure you guys haven't had it easy either. Let me launch Zoom here. Okay, 8.3, sampling methods. Okay, as we mentioned in the previous section, the first thing we should do before conducting a survey is to identify the population that we want to study and avoid any bias or errors in our sampling. Sampling bias occurs if every member of the population doesn't have an equal likelihood of being in the sample. Okay, in 1936, the Literary Digest conducted a poll by mailing questionnaires based on its list of subscribers. Based on its results, the Literary Digest predicted Alfred M. Landon would win 50% of the popular vote. However, Franklin D. Roosevelt won by 62%. What are some possible biases that could have contributed to the study? Well, we don't know anything about the people who read Literary Digest, right? I mean, we don't know anything about them. What the heck? Okay, the people who read Literary Digest might lean to a certain, you know, to a certain political party, right? And maybe that magazine, you know, was leaning to one type of reader, right? So we could say that the Literary Digest could have had readers that what do I want to say? That preferred one political party, or we'll say Alfred Landon's political views, over Roosevelt's. Roosevelt. Okay. Okay, so again, we don't know it. So that's called a biased sample. This is a biased sample. It's a biased sample. Okay. Let's go back to the one that we used yesterday. On Monday, we said that I went to Walmart and I interviewed 1,000 customers, and 59% of them were going to vote for Biden, and 41% were for Trump. So why could this be a biased survey? Any ideas on why this could be a biased survey? Just shout out your answer if you want.
You're not including another chunk of the population because most people who buy at Walmart are either working class or middle class. So you're missing the top 10% of America.
Was that Edsel?
Yes.
Edsel, you're so smart. So that is absolutely correct, right? The people who shop at Walmart, do you think that those are going to be Trump's friends? Right? No, Trump's friends are the people who are like are business owners, right? And you know, all the people who are middle class or upper middle class, right? So could this be a skewed survey? Yeah, I mean, it's the same thing. So this is a bias. This is a biased survey, right? It's a biased survey. It'd be like going to Petco and asking, how many dog lovers do I have here in Petco? Well, you're really not going to get a, you know, good survey there because of the sample that you're going to get is not going to be, you know, is not going to be, yeah. Okay, so Paula says, in what situation would it not be biased? Okay, so what if I randomly called people whose phone numbers end in the digit 9? What if I randomly called people whose phone numbers ended in the digit 9? Right? Like, so if you had, say, 949-691-6999, right? Your phone number ends in a digit 9, then you would be surveyed. Would that be a random sample? Would that be a random sampling? Well, of course, because phone numbers are randomly assigned, right? So am I surveying everyone? No, I'm not surveying everyone. I'm only surveying the people who have the last digit in their phone number as 9. So I'm not surveying everything, a random sample. Okay, so good question. Very, very good question. Okay, so when each member of the population has equal probability of being chosen, this is called a random sample. Okay, great segue, Paula. That was great. Okay, if every member of the population in any group of members has an equal probability of being chosen, then it is called a simple random sample. It's called a simple random sample. Okay, if we identify all likely voters in a state, put each of their names on a piece of paper, toss the slips into a very large hat, and draw 1,000 slips out of the hat, would we have a random sample? So yes, this is another way to get a random sample. The sample is random. Okay, yes, the sample is random. When researchers need to select a large sample, statistical software is usually applied to select the subjects for that sample. Okay, so we can use some software. Okay, the natural variation of samples is called sampling variability. Okay, this is unavoidable and expected in random sampling, and in most cases not an issue. So again, if I take the population here, so this is the population, and I have a bunch of people in my population, okay, and I do a random sample, say that I randomly sample, okay, people over here, and randomly sample people over here, okay, and I get 2 different random samples. I'm randomly sampling these people, but they're just not going to be in the same cohort. Sometimes they'll overlap. Okay, some people in one sample could end up in another sample. Okay, but as long as it's random, we are going to get some variability in the data, but it's expected. right? Example 8.7, if we repeatedly take samples of 1,000 people from a population of likely voters from Washington state, some of these samples might have a slightly higher percentage of Democrats or Republicans than the actual amount of the general population. Some samples might include more older people and some samples might include more younger people, etc. This is sampling variability. So just saying, look, you know, some of them might have more Republicans, some of them might be older, some of them might be younger. So we have variability in the sample, but it's still a valid sample, even though there's some variation within the sampling. Okay. So how do we do sampling methods? Now, some of these are better than others. Okay. It's just depends on which one you want to use, and we'll talk about, you know, is this a good one? Is it a bad one? You know. Okay, stratified sampling. Let's talk about stratified sampling. Okay, in stratified sampling, a population is divided into a number of subgroups, called strata. Random samples are then taken from each group, so they're in subgroups. Okay, and then random samples are taken from each group. So maybe 3 from this group, 3 from this group, 3 from this group, and 3 from this group. Okay, that's a good way to do that. There's a random sample, and then we just kind of take it out all the subgroups. Okay, that's stratified. Quota sampling is the variation of stratified sampling, wherein samples are collected in each subgroup until a desired quota is met. Okay, so we keep taking them until the desired amount of people that we want is met. So say that we want 50 people for our survey, then we would have to take, okay, enough people equally from them until we met a certain amount. Cluster sampling, okay, cluster sampling is a little different in that the population is divided into subgroups, okay, and a set of subgroups are selected to be in the sample. Okay, so say that the population here is in subgroups, okay, 4 subgroups again, and we only choose 2 of them. We just leave the other 2 out. That's called cluster sampling. Okay, and it's I don't think it's as good as stratified sampling. Okay, it's a little less random, so probably not as good. Okay, what about systematic sampling? Systematic sampling is every nth member, okay, of a population is selected. Okay, so this is kind of like you know, if my phone number ends in a 9, right? So what's the probability that my phone number will be end in a 9, right? Well, it's 1 out of 10. Why is that? Because the phone number could end in 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's 10 digits, right? So the probability of my phone number ending in a 9 is 1 out of 10, which means that I'm basically selecting, if I were to do this on a huge scale, I'm basically selecting every 10th person, right? So every 10th person gets selected. So this would be something called systematic sampling, and that's not a bad way to go either. Okay, those are good. This is good. Okay, these 2 are good. This one's excellent. Okay. Convenience sampling, not so good. Okay, that's not so good. Okay, why is convenient sampling bad? Because convenient sampling is simply chosen by selecting whoever is convenient. Again, this is the Walmart example. Okay, so the Walmart example is, right, convenient sampling, saying, hey, you know what? I got 1,000 people in Walmart. I'll just sample them, okay, because it's convenient. Okay, and then this one, not too good either. This is voluntarily response sampling. Okay, so if I post it on social media, do you hate Trump? Okay, and I want to do a survey and says, hey, do you hate Trump? That's going to be a bias sample. Why? Why do you think that's going to be a bias sample? Because
It's voluntary. Just people who want to share their opinion are going to share it.
yeah, and who do you think is going to be more likely to share their opinion?
I'd rather not say. Somebody else say that.
Okay. Okay, I'll say it for you. Okay, I'll say it for you. Okay, I would think that the people who really dislike Trump are going to be the more vocal on this particular topic. Does that make sense? So they have more of a buy-in to. That's a nicer way of saying it. There you go. Okay, that's why I'm the professional. Okay, so yeah, they're gonna have more buy-in, right? They're gonna be maybe triggered more, with this statement, and they're gonna be like, oh yeah, I hate him. Whereas opposed to somebody who is on the fence about him or likes him, probably wouldn't be so triggered by this statement, and they may not respond to the survey. Does that make sense? So voter response sampling, that also is not. Okay, that's also not. Okay. In each case, indicate the sampling method. Okay, every fourth person is selected. Well, that's systematic, right? Okay, a sample was selected to contain 25 men and 35 women. Well, again, that's quota sampling. That's quota sampling. Okay, why? Because I need to fill a quota, okay, of who I'm sampling. Okay, C, viewers of a new TV show are asked to vote via the TV show's website. Okay, so I would say this is voluntary. Okay, I don't think that people are being forced to do this. Okay, yeah, viewers of a TV show are asked to vote, right? Why? Well, you don't have to vote. Okay, you're not being forced to vote, so I'm going to say this is voluntary. Okay, a website randomly selects 50 customers to send a satisfaction survey to. Oh. Random samples are taken. So what is this one going to be? A website randomly selects 50 customers. Okay. What did I put down for this one? I don't know if it's convenient sampling or if it's, this one's kind of hard. This is just a random sample, is really what it is. Okay. It's just a random sample. Okay. I'm just gonna put random. I mean, it's just a random sample. It's really not any of the 5 there. It's just it is just a random sample. Random is, okay, it's called a simple random sample. Simple random sample. That's what I have, and that's what the book has. So I'm just going to go with simple random sample. It's the best one there. I mean, it's not stratified because you're not pulling from different subgroups. Okay, it is just a simple random sample. Okay, and then to survey voters in a town, a polling company randomly selects 10 city blocks and interviews everyone who lives in those blocks. Okay, so they're randomly selecting 10 of the blocks. Okay, and I don't know how many, maybe there's 20 blocks, but they're randomly selecting 10 of them and only interviewing in that 10. What's that called? What's it called when we only select certain subgroups?
Cluster.
Yeah, it's a cluster. Okay, it's cluster sampling. Okay, good job. Okay, 8.4, how to mess things up. How to mess things up, how to get a biased survey. Okay, so sources of bias. Sampling bias, a sample that is not representative of the population. Okay. Voluntary response bias, a sampling bias that often occurs when samples are volunteers. That's sampling bias. Okay, that's like with the Trump, survey. That's the sample. That's sampling bias. Okay, self-interest study. Okay, sampling bias that occurs when researchers have an interest in the outcome. Right. So you see that a lot in politics too. They're like, oh yeah, we had this survey and it said that 59% of voters are going to vote for Biden, and like who? Well, okay, so who ran the survey? Oh, it was the DNC. It was the Democratic National Convention. You're like, there might be some self-interest in that survey, right? So I think it was like 4 months ago, it was like 59% Biden, and now it's come down to 53% Biden. So, so it's kind of like, we'll see what happens here in a few weeks. But I make no predictions. I made a prediction 4 years ago and I was wrong. So I don't make any predictions anymore. All of my predictions do not come true when it comes to elections. So I should predict what I think is going to happen, and then that will be actually the opposite of what would happen. But then, am I just faking myself out? It's a quandary. It's just that's why I stay out of the politics. Okay? I'm independent. I'm neutral. I'm Switzerland. So it's like, forget it. Okay, response bias. Response bias. A sampling bias where the responder gives inaccurate responses. Okay, they're basically lying to me. You are a liar. Liars. Okay, liars. Okay, perceived lack of anonymity. This is like when somebody asks you, oh, did you beat your baby yesterday? You're like, I'm not telling you that. Okay, because if I say yes, it means that I'm a child abuser. And if I say no, it means that I could have beat my baby the day before. So it's called the beating baby question, and there's no good way to answer it. So you're just like, and I'm not going to answer it unless my answer is completely anonymous. Okay, so sampling bias where the responder fears giving an honest answer because his or her response might have a negative effect. Okay, that's every question that my wife asked me. So I'm just kidding. There's the perceived lack of anonymity. I'm like, oh, okay. How do I answer this one? Okay. So yeah. Okay. Loaded questions. Loaded questions. A sampling bias when the wording of the question influences the responses. Okay. So a sampling bias when the wording of the question influences. So basically it says, hey, I bought this dress yesterday. I think it looks good on me. How do you think it looks good on me? Dude, that is a loaded question. Guys, stay away from that question. Okay? She just gave you the answer that she wanted. And so you better tell her that she looks good in it if she thinks she looks good in it. Right? That's called a loaded question. Okay? So it's basically, yep, you look awesome. You look amazing. Okay? Even if it's like a paper bag she's wearing. You're just like, yep, you look amazing. It's great. So at that point, she's not asking for an honest opinion. She's asking for her opinion to be validated. There you go. Okay, non-response bias. A sampling bias where people refuse to participate in the study. Okay, basically they're like, no, I'm not participating. Okay, and the people who do participate, they have a vested interest in participating. Okay. Okay, in each situation, identify the potential source of bias. Let's look at this. A survey asks a person for the number of sexual partners he or she has had in the past year. Okay, well, that's a little personal. Okay. However, in recent months, I've noticed that people will actually be more apt to answer this question than who they're voting for, which is kind of interesting to me. So perceived lack of anonymity. Yeah, I'm going to go with that one too. Okay, anonymity. Okay, I do not want people knowing my personal answer to that. Okay, unless it's completely anonymous. Okay, so anonymity. Okay, I don't want people knowing who I'm voting for. Okay, I'm just like, no, who are you voting for? I'm voting for Tom Brady. Okay, quarterback of the Patriots. So, yeah. So there you go. That's who I want for president. Okay, a radio station asks listeners. Okay, a radio station asks listeners to phone in their choice on a daily poll. What's this one? Yeah, this is voluntary, right? This is voluntary. So there's voluntary bias there. A substitute teacher wants to know how students in the class did on their last test. The teacher has 10 students sitting in the front row. Well, I would say this is sampling bias. Okay, you're doing the front row students. Okay, you're not polling everybody. So I would say this is sampling bias. Okay, high school students are asked if they have consumed alcohol in the last 2 weeks. Okay, what could this be? Any ideas on what this could be? This could actually be 3 of them up there. Can we pick out the 3? Response. Caitlin says response. Absolutely. Okay, look at response bias. What does it say? It says a sampling bias where responders give inaccurate responses. Okay, they're liars, basically. High school students are liars. I don't know. Some of them aren't. Okay, so this is response. Okay, and non-response. Yeah, why would some of them are just gonna refuse to participate? Non-response. Like, sure, I've done drugs and alcohol the last week. Sure. No, I'm not gonna admit to that. Okay, and then what's the third one? The third one is, anybody know? How about lack of anonymity again? Yeah, perceived lack of anonymity. Anonymity. Right, okay. The Beef Council releases a study saying that consuming red meat poses little cardiovascular risk. Well, are you really gonna believe what the Beef Council tells you about red meat? I mean, this is a self-interest study, right? This is self-interest. That's self-interest, I know that. A poll asks, do you support a new transportation tax, or would you prefer to see public transportation system fall apart? Well, that's not opinionated, is it? Like, well, that's a loaded question. Okay, that's a loaded question. Okay. Okay, 8.5. Okay, I want to go over this real quick. You don't have homework on this, but I still want to go over it. Okay, 8.5. So far, we have primarily discussed observational studies, okay, where conclusions are drawn from observations of a sample or population. So we're just looking at observations. Okay, in contrast, it is common to use experiments when exploring subjects reacting to an outside influence. In an experiment, some kind of treatment is applied to the subjects and the results are measured and recorded. Okay. So let's talk about global warming for a second. Oh, I know, it's a lovely topic, right? There's nothing loaded about this topic. And I don't really care where you fall on the issue. We're just going to talk about experiments versus observational studies and why global warming is such a heated debate topic. Okay. Okay, we're just going to talk about why it's a debate topic. We're not going to talk about who's true and who's false. Okay. So with global warming is called something called an observational study. Okay, global warming is an observational study. What does that mean? It means that people have observed what? That the seas are getting warmer. They've also observed that the climate is getting more, what do we want to say? I don't want to say random. It's just getting more extreme. Let's just say that. It's getting more extreme, right? Okay, and this is an observation made. This is an observation, okay? Now, what else have people noticed? Well, they've also noticed that what? Carbon emissions have increased over the last 100 years. It's probably over the last 150 years, but we'll just say over the last 100 years. Right? And what is that? That's another observation. Okay, these are all observations, right? Seas are getting warmer, climate is getting more extreme, carbon emissions have increased over the last 100 years. Now, this is why is this an observational study? Well, it's an observational study because you can't really repeat this experiment in a laboratory. You can't say, oh, okay, well, we have the world climate and we have the world oceans and we have carbon emissions, and we can repeat this experimentally. So it is not an experiment. Okay, in order for something to be an experiment, you have to have repeatable, okay, repeatable outcomes, and you have to be able to change the variables, right? You'd have to say, oh yeah, we eliminate carbon emissions, and then the seas don't get any warmer, right? But we can't do that. So the problem comes with something like this, and why it's debated, is that there is something in statistics that says correlation does not prove causation. Correlation does not prove causation. Now, what does that mean? Okay, correlation does not prove causation. Now, could that one be causing the other? Absolutely. Are they correlated? Absolutely. Does one necessarily cause the other? That's up for debate. That's why there's a debate. Okay, correlation does not prove causation. It means that, hey, if ice cream sales go up, and air conditioning sales go up, well, are these two things correlated? Is there a correlation between them?
No.
Well, there is a correlation. When ice cream sales go up, air conditioning sales go up, right?
Oh,
Is there a correlation between them? Yes. Now, does one cause the other?
no.
No, one does not cause the other. There is a third extraneous variable that's causing these, right? What's the cause of this?
Heat.
Yeah, it's the heat. Okay, it's the warm weather. Okay, and so just because these two things are correlated doesn't mean that they're causing each other. Okay, so that's just something in statistics that we're going to have to learn. Okay, so to go back to what is an observational study, this is an observational study as opposed to an experiment. Okay, so what's an experiment? An experiment has something called a control group and an experimental group. And in the control group, you have something called a placebo. Okay, it's basically we're going to introduce something that doesn't affect the outcome. Okay, and the experimental group, you have, okay, your actual, what is it called? It's called, gosh, I forget what it. I can't think of the word off the top of my head. Okay, it's basically the variable that you want to change. So I'll just call it the variable of change. Okay, it's a thing that you want to manipulate. Okay, it has a word. I just can't think of the word off the top of my head. Okay, but it has a word. Okay, it's the variable of change. It's the thing that you want to change. Okay, whether it's a medicine that you're introducing, or a catalyst of some kind. I think that's what it's called, catalyst. Okay, some sort of catalyst for change. Okay, that you're introducing. It doesn't have to be medicine. It could be you're introducing a noise, or you're introducing a person, or you're introducing something into the experimental group that, you're introducing some sort of criteria that you're going to change. Okay, now you're going to introduce the exact same thing in the control group, but that's not going to have any effect. Okay, so that's an experiment. And the one thing that makes this experiment an experiment is that the results are repeatable. Okay, the results are repeatable. Okay, whereas an observational study, because all you're doing is observing what's happening. Okay, in each scenario describing an observational study or an experiment, okay, the weights of 30 randomly selected people are measured. Well, am I introducing anything new in that? No. So all I'm doing is observing this. This is observational. Okay, subjects are asked to do 20 jumping jacks, and then their heart rates are measured. Is this observational or experimental? Can I have a control group? And can I have an experimental group? Well, yeah, the control group are the people who don't do the jumping jacks. Don't move. Okay, these are the jumping jack people. Can I repeat this experiment as many times as I want? Absolutely. Okay, can I measure the heart rates? Yeah. So the variable that we're measuring is heart rate. Okay. Okay, and we're saying do jumping jacks cause an increase in heart rate? So yes, this is an experiment. Okay, meets the criteria for experiment. It says an experiment is a study where the effects of treatment are measured. A treatment is applied. Well, in this case, what is the treatment? The treatment are the jumping jacks. That's the treatment. Okay, a treatment is applied to the subject of an experiment for a duration and then measured during the course of the treatment. Okay, so jumping jacks is the treatment. Okay, 20 coffee drinkers and 20 tea drinkers are given a concentration test. Okay, so is this an experiment, yeah, we could actually have a control group too. We could have coffee, tea, and then water, right? Here's your water group, right? And then what are we doing? Well, we're giving them a test. Okay, so we're saying, in each of these, we're giving them a test. Could I repeat this experiment? Absolutely. Is it an experiment? Yes. Can I have a control group? Yes. So it's another experiment. Okay. Confounding occurs when two potential variables when there are two potential variables that could have caused the outcome, and it is not possible to determine which actually caused the result. This is confounding. Okay, there is a confounding variable out there that could make the results happen. Okay, so a drug company claims people lost an average of 8 pounds while using their weight loss pill. Okay, what could be some other variables or some confounding variables that cause the weight loss? Is this confounding? Why or why not? Okay. Okay, so well, what's one cause of the weight loss? One cause of the weight loss is the pill. Another cause of weight loss could be diet.
Working out.
Another cause of the weight loss could be exercise. And another cause of the weight could be like thyroid issues. Who knows? Okay, hormonal issues, right? So these are all what we would call confounding variables. I'm not writing well today. These are confounding variables. Okay, these are confounding variables. Okay. So is it confounding? Yes. It's confounding because other variables were present, okay, that could have caused the same result. Okay, participants of an experiment are divided into 2 or more groups, typically a control group and a treatment group. Okay, that's what it is. It's called the treatment. I don't know why that escapes me. Okay, you have a placebo and you have a treatment. Okay, the treatment group receives the treatment being tested. The control group does not receive the treatment. A placebo is a dummy treatment given to the control group for the placebo effect. The effect of a treatment influenced by the patient's perception. An experiment that gives the control group a placebo is called a placebo-controlled experiment. Okay, determine a reasonable placebo for each scenario. The study of a new medicine that is dispensed in pill form. So, how about a sugar pill? A pill that just has sugar in it. Okay, that would be my placebo on that one. Study on the effect of alcohol on memory. How about a non-alcoholic drink? I can't spell today. Alcoholic drink. Okay. Okay. A frozen meal diet plan. How about a frozen meal with more calories? Okay, frozen meal with more calories, and that's your placebo. Okay. In a blind study, the participant is not informed whether he or she is receiving the treatment or the placebo. That's a blind study. Double blind is when all of the participants in the study, including the researcher and the subjects, are not informed which subjects are in the treatment group. Now, if someone needs to know who's in it, but that's an outside observer. It's an outside person. That's somebody outside the experiment. The outside observer will know who's in each group, but not the person conducting the experiment. The experimenter will not know who's in what group. So the experimenter is going to treat all of the participants the same. Okay, last example. To test a new lie detector, two groups of subjects are given a new test. One group is asked to answer all the questions truthfully, and the second group is asked to lie for one set of questions. The person administering the lie detector test does not know what group each subject is in. Does this experiment have a control group? Is it blind, double blind, or neither? Okay, so is there a control group? Yeah, what's the control group? Okay, the control group is the people who answer truthfully, I suppose. Okay. The experimental group is the ones that are lying. These are the liars. Okay. The person administering the lie detector check does not know which group each subject is in. So that's double blind. Because not only do the people in taking the test don't know which group they're in, the experimental does not know either. So that's a double blind test. Okay, and this is what this is called. If you have a placebo, and if it is double blind, that is actually called something called the gold standard. This is the gold standard. Gold standard for experiments. Okay. If you want a gold standard experiment, you're going to make it have a placebo and you're going to make it double blind. Okay. Well, that's it. That's all I got for today. Okay, I'll see you guys on Monday. Make sure that you do your homework and make sure that you do this week's worksheet and turn that all in by Sunday. Okay. Okay, and if you came in late, let me know. See you later. Thank you.